Welcome to the new Transatlantic Cable, a tripartite civil engineering history webinar series. The webinars are coordinated by the History and Heritage Committee of the American Society of Civil Engineers, the National History Committee of the Canadian Society for Civil Engineering, and the Panel for Historical Engineering Works of the Institution of Civil Engineers. Today's installment, recorded on May 18th, 2022, features Mike Chrimes presenting William Strickland and British Tunneling Practice.
Well, it is now 6 p.m. in the UK, 1 p.m. in London, Ontario, and 10 in the morning here in California. So we will start our webinar. Okay, the topic today is William Strickland in British Tunneling Practice. Welcome, my name is Chuck Spinks. I'm the past chair of the American Society of Civil Engineering History and Heritage Committee. I'll be your host today. We are calling this our Transatlantic Cable webinar. It includes the three engineering societies, American Society of Civil Engineers, the Canadian Society for Civil Engineering, and the Institution of Civil Engineers in the UK. The topic today will be presented by Mike Chrimes. We will have Q&A after the talk, and you will have an opportunity to discuss the talk and to ask questions. And as I said, this is a joint meeting of the ASCE, CSCE, and ICE, and we have started this. This is the second in a series, and we hope to have a continuing program. We plan on targeting quarterly talks, and at the end of the presentation today, we'll bring up our next proposed talk. The speaker for today is Mr. Mike Chrimes, MBE. And Mike spent 37 years with the Institution of Civil Engineers from 1977 until retiring in 2014. He was head of knowledge transfer and the director of engineering policy and innovation at ICE. He has presented papers at ASCE, CSCE, and ASCE conferences and written a number of books and articles on the history of civil engineering. He was honored as a member of the Order of the British Empire and was awarded the ASCE History and Heritage Award. Mike, the floor is yours.
This is really a follow-up to some work I've been doing about Thomas Telford's tunnels. Telford's better known really as a canal engineer and bridge engineer, and as the Colossus of Rhodes, with a career spanning from about 1780 to 1834 when he died. So I became interested in the fact that Telford's tunnelling work had been little studied. And so I'm going to talk a bit about that, and then about how he might have found out about tunnels when he began his career as a canal engineer in 1794. And then my realization really of the significance of William Strickland's work in recording what had been done in the UK in the early 19th century, and whether indeed he might have had influence both in the UK and in North America through the reports he'd done on it following a visit to the UK in the mid-1820s. So that's the plan. So the canal age in the British Isles began around 1760, and really for the first 30 years or so, it was dominated by James Brindley, who pioneered the canal with the Bridgewater Canal, and then a number of canals across the Midlands and northern England. In the 1760s, he died around 1770, but his colleagues carried on. So how would these people have found out about tunnelings? Well, in the case of Brindley and some of his assistants, they were familiar with mining practice. In continental Europe, there were some mining schools, so you could have perhaps learned about how to drive tunnels in that way. But the main way that people must have found out, I think, at that time was by speaking to colleagues, or if you were lucky, if you had access to them, getting hold of engineers' reports. But it would have been difficult, unless you're able to visit works yourself, to find out about tunnels, because there were no published records really in the way that we'd expect today. So when Telford began around 1794, he would have relied on speaking to people who worked in mining, finding out about geology. He worked with an engineer called William Jessup, who already had carried out work on canals and driven a number of quite long tunnels, a couple of miles in length. So basically, I discovered through my research that nothing much had been published directly on what we now consider tunnel engineering. And the reason I chose the date of 1806 as break date, if you like, was in 1806, after nearly 50 years of canal construction and canal tunnel construction, an article was written by Joseph Fairy in a cyclopedia which appeared in both the UK and then in the United States, which does talk about how you would go about building canals, but not illustrating how you would do it. So from 1806 onwards, you could get some advice. There were also a number of visitors who published on British canals, but again, nothing much before 1806. Nothing much really giving any detail of construction until 1820, when some prints, which I'll show an example of, appeared. And then we have Strickland coming to the UK in 1825 and his reports being published in 1826. But it's not until the following decade that there's an English publication that gives any real detail of the engineering of canal tunnels. So Strickland anticipated this really by a decade or so. For the sake of certainly the UK audience, I'm going to say a bit about Strickland in a moment. So this is a nice portrait with one of his major works in the background. Although he was born in New Jersey, really, his father became a Philadelphia master carpenter, and Strickland was really brought up there. Then he became a pupil as a teenager of Latrobe, who I suppose is one of the best known, if not the best known, of the early generation of architect engineers in North America. It's not clear how much he learned from him. He seems to have disappeared from the office on occasions in his short apprenticeship, but he seems to have been involved in surveying the town of Newcastle and also probably worked on the Chesapeake and Delaware Canal, which was under construction at that time. And he followed Latrobe's example over the next 30 years or so, practicing both as an architect and engineer, and is really well known as an architect of the Grecian or classic revival style, which was dominant, I suppose, in North America as well as in Europe at that time, and made his reputation really with the design of the Second Bank of the United States around 1820. And that opened doors for him in a number of ways. As for his civil engineering, he obviously took an interest, perhaps inspired in part by working with Latrobe, in contemporary developments in civil engineering, and the well-known article on James Finley's chain bridge, which appeared in the portfolio in 1810. That illustration was drawn with detail by Strickland. So he was obviously au fait with developments in civil engineering in North America at that time. And he carried out a number of works, involved with canals, but interestingly, the only ASCE historic landmark I can find is the Tennessee State Capitol, which is built late in his career, which has an interesting wrought iron framed roof. To all appearances, appears an architectural rather than engineering work from the exterior. Anyway, his architectural work around 1820 cemented his reputation in the Philadelphia area and led to his being elected to both the American Philosophical Society and the Franklin Institute. And leading citizens of Philadelphia at that time were concerned about the loss of economic status, compared particularly with what was going on in the northeastern states and New York. And so, because of his reputation and background, he was paid for a trip to the United Kingdom to report on infrastructure by the Pennsylvania Improvement Society in 1825. And his reports, published the following year, became well known for the description and his support for railways, but it's not the only thing that those reports covered. They're in a number of sections, and they seem to have been made available, certainly to his supporters, as he sent them home. And the first ones were really dealt with railways and the coke industry and steel in June, and that was followed by his essays on canals and harbours, then roads, then iron manufacture of gasworks. And the reports are presented in roughly chronological order, and the plates similarly in their 1826 form, but they were available to people in Philadelphia before that time, which I think becomes quite interesting. From his own point of view, I suspect the most significant thing was that the harbour works and dock works he visited, and he almost immediately became involved as engineer for the Delaware Breakwater, which apparently is the first rubble mound breakwater in the Western Hemisphere, much altered today. But he was involved with that for about 15 years under construction. Well, this is probably the most famous image that came out in his reports, which is of one of George Stephenson's early locomotives. And he actually came back with a model locomotive, which was presented to the Franklin Institute, which I believe still exists there. So the influence on his career is quite clear, in the sense that he went on and built that breakwater, and his recommendations on railways, report on railways are well known, but his canal suggestions, and particularly his tunnel plates, I think really have been largely ignored. So when he came over to the UK, the Liverpool and Manchester Railway and its engineer George Stephenson were just getting going. And one of the first bits of that line to be commenced was the Wapping Tunnel, which connected Liverpool docks to the main line going across to Manchester. And this is a drawing from the Telford collection of that tunnel. The tunnel's not mentioned in the reports, but he would certainly have been able to see preparations being made for this work when he visited Liverpool at that time. So who, apart from the Philadelphia, Pennsylvania Improvement Society, subscribed to his reports? Well, there's an Appleton who may well have been a contractor, and then a number of quite well-known and lesser-known figures in engineering: Loamy, Baldwin, Simeon Guilford, Jonathan Knight, Stephen Long, Dennis Mahon, Colonel Totten, Sylvester Welsh, W.H. Wilson, Benjamin Wright, and then some of the early canal companies that really were trying to get going and needed information on how works were being carried out in the UK to help them with their work. And this is one of the reasons that Strickland was sent over. What I found quite interesting was, if you look at the early American tunnels and the engineers involved, there were a couple done before Strickland's report, but the Union Canal Tunnel, one of the engineers on that, Guildford, was one of the subscribers. Canvas White, of course, had already been over to the UK and seen canal works while he'd been over. Then the Pennsylvania Canal, which Strickland himself was involved with, and Wright and Welsh, another subscriber, and then really the Associated Portage Railroad. Again, Welsh was the engineer, contractor Appleton. I'm not sure about the Harrisburg tunnel, but Roberts had obviously already been working a decade earlier with people like Guildford, so he must have had access to these reports. And so it goes on. Wilson was another subscriber. Gill and Hage had worked on the Pennsylvania Canal when they were doing the Sandy and Beaver canals in the late 1830s. So I think it must be assumed that most of the engineers involved with early North American tunnels must have had access to Strickland's reports. And of course, that wasn't the only way to find out. People went themselves, and there's a whole, perhaps 20 to 30 people have been over, and they've been looked at by Darwin Stapleton. So these people would have been able to see for themselves. So you can't see Strickland as being, by any stretch of the imagination, the only source of information. Many of the early railway engineers went over to have a look for themselves. But I think it's fair to say, really, there was no much detail or mention of the tunnelling achievements of British engineers before Strickland's visit. And what might you have expected, I suppose, what you might have expected from a 19th century or treatise on tunnelling would be a plate like this, which is one of Telford's plates of Chirk Tunnel, which was done in 1790s. But these illustrations did not appear until after Telford's death in 1838. So there was nothing to look at like this in the early 19th century in terms of publications or readily disseminated information. Instead, what one can see here is one of the late 18th century canal tunnel entrances. Then there's a cross section from a book by a German visitor, Van Meyert, who visited in the 1790s, but didn't publish his findings really until after 1810. And it shows a cross section of one of the Brindley tunnels with massive sidewalls, which calls into question how accurate it probably was. And then at the top there, we've got a view from Strickland of how these shafts, working shafts, operated with a horse gin at the top in most cases, although in his text he actually mentions the use of steam engines for pumping. But this is the normal way that longer tunnels would have been built and material got in and out from them. So Strickland's really got illustrations of the plant on the English tunnels for the first time. And you can see in this Ackerman print here, the larger illustration of Regent's Canal, which was under construction around 1820, just before Strickland went there. And you can see the bottom end, if you like, with the bucket to take material out and bring bricks and the like down. So that's pretty much the first illustration we see, artist's impression of tunnel works. And this is about 1820, the entrance to the tunnel in the photograph as it is today. And then there's a drawing from the Telford collection of the supporting formwork. And this was published about 1820 in a very sort of thumbnail way by a French observer, but nothing like the quality. You wouldn't have been able to work out how to do it from that very small drawing. Just to give you a feel of what I'm talking about there. This shows an illustration of a cross section showing the shaft coming down of Strood Tunnel on the Thames and Medway Canal. This is from a French book of 1841. They've taken this plate really and much reduced it from one of Strickland's plates. So Strickland saw the Thames and Medway Canal. It was a project that began around 1800, but they ran out of money and the engineering difficulty of the tunnel proved too much until about 1817, when William Tierney Clark was appointed engineer, and Telford initially advised the government to give it no money, but relented later. The contractor was a chap called Pritchard, who we'll come back to, who gave Telford various information. But this tunnel was pretty much the state of the art in 1820, and it's one that Strickland reported on in his reports. And these are three of the plates from Strickland's reports. So at the bottom there's a part of a longitudinal section, and you can see that there are both working shafts coming down, in one case with some indication of the plant being used, and also there are thinner lines which represent air shafts. And in Strickland's description, he explains how, because of the foulness of the air, it was proved necessary at irregular intervals to place these ventilation shafts along the line of the tunnel. And they used, well, what I describe as mine ventilation technique. They used fires to create drafts in the tunnel to try and draw air through. So this is the section of part of the tunnel. Then above that, we've got a cross section through the tunnel, and that shows both the tunnel pretty much as complete with the towpath in place, shaft coming down, and also an indication of the working. And then on the right, as you look at it, you can see the special formwork that was designed by the contractor, Pritchard, and this could be assembled and disassembled using wedges, and they had a scarf joint which could be assembled and disassembled across the base of the centering, supporting the brick arching. And reverting to the cross section showing the completed tunnel, I think there are a number of things to observe. One is that generally on this tunnel, the arch sprang from the rock, and the method of proceeding which Strickland described was for the miners to drive a heading between shafts, and once they finished that, then they would begin to open out and place the centering at suitable intervals as they moved along, and disassemble it and move it along further. You can see that the side wall, if you like, of the arch is thicker than the top. It's also, interestingly, the shaft was not brought down to bear on the arch ring, and there's a space above which they filled with rock and rubbish. And the miners were able, as they finished the tunnel, the miners came back down through a hole, and the actual arch ring brickwork was built in from above on the centering rather than below, which makes sense. And where the rock was unstable, as they opened it out, they used props, which you can see alongside there. The numbers of props and the safety of the rock varied with the geology. It was obviously quite a risky business. Anyway, this is pretty much state-of-the-art tunneling, and one thing that distinguished it from what went before was something else that Strickland illustrated, which was that they used observation towers with a transit instrument which could be sent in both directions. So the observation towers were built on the highest points of the alignment, where they could be observed between each other, and the transit instrument could be spun over so it could be ensured that it was in line on both sides. And once they were convinced about the line of the tunnel, they then took off, determined the depth, and as the shafts were sunk and the heading pursued, they could keep it all pretty rigidly in line. And that hadn't necessarily been the case with other tunnels, which had inconvenient bends and the like. And one wonders whether the reason that it was possible to produce a longitudinal section for the first time of the tunnel was because of the excellence of the survey work. They actually knew where they were in a way that hadn't been possible before this. And more detailed version of these plates appeared in the first treatise on tunneling, practical tunneling by Sims in 1844. This is nearly 20 years later. You couldn't have hung around to wait out how to do this. People must have been aware from what Strickland had done that this was the way to go forward for nearly 20 years. The other tunnel that Strickland was able to visit and describe in some detail was the Harecastle tunnel on the Trent and Mersey Canal, which was a doubling of a tunnel that had been designed by Brindley in the late 1760s, but proved inadequate in terms of its construction and also its size as well. It didn't have a towpath. It was very slow to get through. It was one of the longest tunnels on the British Canal network. So if one looks at this, one can see that Telford, who was the engineer, determined to line the whole thing throughout with brickwork. He used a hydraulic cement, hydraulic lime naturally occurring with hydraulic qualities to deal with the water and make sure it wasn't washed out. But you can see that the contractors, who again Pritchard and Hoope, had developed a different form of centering, which in this case had sort of keys to lock the bits together as they went along, and it operated in about, I suppose, 10-foot lengths with timber sheathing resting on top of the centering or forms, and as they went along they would withdraw the last bit and put it forward and move the sheaths, the timber planking forward, enabling it to be built within about 3 years, and the first one had taken about 10 years. And you can again see there was a lot of loose rock above the arch which had to be backfilled, and again the shaft isn't brought to bear upon the brickwork, which was to be true on the early railway. The railway engineers worked out a way of doing this with cast iron, basically derived from mining practice. So what we've got here really is that Strickland came really to and observed the tunnels of the last phase of the Great Canal Age in the UK, where tunnelling techniques had been perfected to an extent, and was able to show how that was done. But he did this for the first time, and there was nothing like this before available on the British Canal tunnels. So he was able to show state-of-the-art tunnelling in 1825 in a way that nobody had done before. And just to emphasise this point, these are another set of figures, plate from Telford's Atlas, published in 1838, so 4 years after Telford's death, with all the detail on. There's some modification to what Strickland was able to show, but close enough to know that we're looking at the same work, and people would have been able to work out what was going on from Strickland's notes and the drawings 10 years before they could have seen the same information from this work by Telford. And indeed, more or less the same time, 1838, Sims published by Wheel, Public Works of Great Britain, shows the first railway tunnels at that time. Wheel actually reused some of Strickland's plates in this work. Clark's supplied some of the Thames and Medway plates, and then Wheel rehashed some of Strickland's plates in the Public Works of North America, which interestingly show no tunnels. So for the tunnels, you have to go back to the 1820s, and I think it's a remarkable achievement, given that nobody tackled this before, that Strickland was able to do this and make them available to a North American audience as well as one suspects as British Railway engineers. And by the time the Sims Public Works comes out, this is a German magazine, German language magazine, Allgemeine Bauzeitung, published 1839, showed in detail how tunnelling work was processed, so in more detail than Strickland was able to. So, 10 years later, so for 10 years, people have been a bit in the dark about all this if they wanted to see how it might be done, and had no ability to carry out personal observation. And then in 1844, Sims produced another book, which is the first, as far as I know, English language textbook on tunnelling, with a great deal of detail on how tunnelling work was being progressed at that time, with the same kind of illustrations of the horse gins that Strickland had produced 20 years before. So more detail on the actual tunnelling itself, but Strickland had shown the way. So our conclusions are basically that Strickland's reports provide the first detailed drawings of tunnel construction in English. They illustrate the state of the art in canal tunnelling in the UK in 1825. They were available to engineers before tunnel construction had begun in the USA in earnest, and by extension as well before railway engineers had begun to build tunnels merely in the 1830s in the UK. Many of the key players in the USA had copies of this, but of course many US engineers went to the UK to see for themselves, possibly prompted by Strickland's example. But I think the whole thing does show that Strickland's canal tunnel plates remain a great source of information on early canal tunnel construction. And it's not just either his research into how you built breakwaters, which is part of his study tour, or his advocacy of railroads that needs to be remembered. His work was of greater significance than perhaps people on either side of the Atlantic have realised. So I'm quite happy to take questions there.
Thank you, Michael. Excellent presentation. And I think definitely Strickland is underappreciated here in the States for his contributions. And here we are back again. So please, if you have questions, either use the raise hand feature, or you can type in to the Q&A section your question for Michael. Here's one, Gordon Masterson.
So, yeah, that's Chuck. I think I've been unmuted by Mike. That was fantastic, Mike. And I'm not surprised at all just how thorough and detailed your research has been on this. And I hope you plan to publish this, piece somewhere. I'm sure you'll have opportunities to do so. And my observation really is that it must have, for any young students, who I hope some might be on the call or see the video later, this must look like a different universe. In the modern age, we're accustomed to seeing pretty much now real-time information bombarding us from all directions. And here you are, not that long ago in the big scheme of things, a couple of 100 years ago, where information could take 30, 40 years to disseminate. Have you got a feel from the point at which the projects were happening until the general formal publication? Have you any feel for the informal sharing and networking through sketches, sketchbooks, the things ephemera that'll be probably lost to us today from an archive search point of view? But was there evidence of sufficient communication prior to publication within the network of engineers on both sides of the Atlantic?
I think if you take Telford as an example, one has to assume that when he did the Churt Tunnel, which was the first one he was asked to do as a I'm going to say a resident engineer in a sense, but he must have asked William Jessup how to do it. There was also people close by who had minds who he could have asked. And coincidentally, he was asked to do research on Roman cement for a harbour job. So he was interested in hydraulic cement. So there's a number of things coming together. But unfortunately, the paperwork on which his life was based, and particularly the plates, which were at the Institution of Civil Engineers, quite clearly from the list of documentation, they don't exist. So it's not clear how what his specification actually said. It's known, however, that prior to the 1790s, some of the first tunnels that were built, the contracts were just on to coin a phrase, back of envelope jobs, and there was no detail at all. So their contracts are often undertaken by miners, so they'd have known how to dig a hole, but all the advice on how to build the thing would have been reliant on good supervision by assistant engineers. And I suspect there was an element of trial and error, certainly on the thickness of the brickwork where it was necessary, because sometimes they were exposed rock, and some of the early tunnels in North America as well seem to have been unlined rock. Well, so I think people must have relied heavily on colleagues, and there aren't drawings to show what they could have been sharing, but I'm quite sure that it would have been possible to see cross sections of the brickwork in some of the late 18th century offices. It's a bit unfortunate that I suppose John Smeaton, who was the leading engineer contemporary with Brindley, wasn't really responsible for any tunnels at that time, because his drawings do survive, and Brindley, we don't have really any drawings. But I'm sure that people did share, must have shared. It's just that if you wanted to start from scratch, you'd have had to find somebody who'd done the job. And so it really was, dissemination must have been through personal contact, and that I think would have been just as true in North America, really.
Okay, thank you. Michael, we have another question from Mr. Nistor. It is a question: any applications of these methods for specific projects using these plans in the US? So I guess, were there any tunnels that you think specifically used the contributions of Strickland?
I don't know. I mean, not all of the tunnels, those early tunnels I think that were built survive. And I think the need for sophisticated brickwork supported on centering may not have been universal at that time. But I think it would have given people confidence to go forward in a way. And he did describe how to deal with difficult geology and the like. So more work needs to be done, I suppose.
Well, talking of difficult geology, there's a question from Nigel that the plates show digging through clay-type materials. How did they progress through rock?
Well, no, both these tunnels that I showed, they are tunneling through rock. The Thames and Medway's through chalk of variable consistency, and the Harecastles through coal measures, again with some issues, but some of it was very hard rock on the Harecastle. So some of these tunnels they did use blasting on, but there's no evidence that was being used on the ones that I'm talking about. It was pickaxe and shovel, and probably with some, well, certainly with some railroad, in terms of human mine type railroad underground to move the muck around underground. They are through rock, these two tunnels.
Okay, another question from Dennis Broadhurst. To what extent did the early tunneling pioneers Telford et al. Perform engineering calculations for design of plates and other structural components. As you have mentioned, it is likely that most of the applications would have been based on practical experience.
The only calculations I've seen are arithmetical ones to do with likely rates of progress. So that would have been based in a sense upon the hardness of the material and past experience. But I don't think that they had any, well, I'm sure they had no real concept of earth pressure, if you like, or rock pressure and bursting. And that was demonstrated sort of in the 1830s in the UK when they started to tunnel through London clay, and the lining that was originally specified was woefully inadequate for the pressure of the ground. And so they basically thickened the linings up, and I think that would have been generally the case. You got it to stand. And on the Regent's Canal, which is in London, the timbering in that drawing, which may not have been that clear, was very heavy indeed. There was no calculation, I'm sure, as such. It's just what they think, put in a timber that will take the strain, I suppose. The Harecastle and Strood centering looks much less substantial.
Thank you. I don't see any more questions. Are there any more out there? Thank you very much again, Mr. Chrimes. And our next webinar, this is, as we said in the beginning, this is our second of what we hope will be quarterly webinars. We do have and anticipate having one in September the 28th. That is a tentative date, and I think we have a tentative topic for that. Is that correct, Mr. Bartlett?
Yep, that's right.
So we are done for today. Please keep your eye out for more news on the next one coming up in the fall. We are taking off for the summer. And thanks again, everyone, for participating.
The new transatlantic cable webinars are coordinated by a tripartite ad hoc committee that includes the individuals listed here.